Hello everyone. Today we're going to learn how to read a verbal description of some kind of scenario and turn that into a linear equation. Once we have the linear equation, we would be also able to answer some follow-up questions. So let's read this example. We have an airplane that is 30,000 feet above the ground, begins descending at the rate of 2,000 feet per minute. Assume the airplane continues at the same rate of descent. The plane's height and minutes above the ground can be represented as a linear function. Now for all of these questions, the very first thing that we're going to do is determine what is the independent variable and what is the dependent variable. So you're going to look at the two quantities that are being described in this written description. The first that we have, it says here that the plane's height and minutes above the ground can be represented as a linear function. These are going to be our variables. Typically, the independent variable is your input, so the x value. And this is what does not get affected by anything else, hence why it's called the independent variable. In most cases, the independent variable would be time. And in this particular example, we are given the time in minutes. I like to write out what the variable is as well as what its unit of measurement is. That way later it'll help us with our future analysis. For our dependent variable, that is going to get affected by the independent variable. And the dependent variable is always your y value. Now in this particular case, since our plane is descending, that means that its height is changing. Therefore, the dependent variable would be the height of the plane, which is in feet. The next part we're going to evaluate is what are our given information. And those are going to be the numbers. You're going to look for what these numbers represent in the context of the problem. We are told that the airplane is 30,000 feet above the ground at the moment it begins descending. Since this is the plane's starting point, we would say that would be the y-intercept, which is b. So b is going to be 30,000. We also see that the plane is descending at a rate. Whenever you're given rate, this is your slope. Now because it is descending, that means that the height of the plane is going to decrease. And if you ever have the dependent variable is decreasing, that means that your slope is going to be negative. And it is negative 2,000 feet per minute. Whenever you see this word per or every, that tends to signify that we're looking at our slope because it is a rate. Now since we have our slope and we have the intercept, we are going to write this equation in slope-intercept form, remembering that the equation is y equals mx plus b. Since we have m and we have b, we can say that our equation is y equals negative 2,000 x plus 30,000. Now we're going to answer the follow-up question. It says to use the equation to find the altitude, which is just another word for height, after the plane after 5 minutes. Now, whenever you're given another value, we have to determine where am I going to plug that in. So I have 5, and I need to see, am I going to plug it in as x or as y? And this is why I write down my units. Notice that the 5 is minutes. From looking at the x and the y values, we see that x represents minutes. So I'm going to plug in x is equal to 5 and solve for y, which will give me the height of the plane, which is what I'm looking for. So we would have y is equal to negative 2,000 times 5 plus 30,000. Then we just work this out. Right? Negative 2,000 times 5 is negative 10,000 plus 30,000 is going to give me 20,000. And remember, since we're solving for y, which represents height, this is in feet. So after 5 minutes, this means that the plane has a height of 20,000 feet. Moving on to our next example. Suppose you receive $100 for a graduation present, and you decide to deposit it into a savings account. Then, that's supposed to be an N, each week thereafter, you add $5 to the account, but no interest is earned. The amount in the account is a function of the number of weeks that have passed. Now the problem actually tells you what the variables are. The independent variable and the dependent variable are given in this last sentence. It says the amount in the account is a function of the number of weeks that have passed. Typically, and I wrote it here, the dependent variable is a function of the independent variable. Therefore, our independent variable is the number of weeks. Again, we have time, and the units is in weeks. Our dependent variable, remember, is affected by our independent variable. And in this particular case, the dependent variable is the money in the account. Now we're going to look at what is the information that is given in this problem. We have this $100 that was given as a graduation present. This is the amount of money that we initially deposit into the account. That means that B is equal to 100. Then each week, this is a key word, each. That typically means that we're looking at the slope. We are adding, meaning that the amount of money is going to increase $5. So we're adding $5 every week. That is our rate. So the slope is a positive 5, since the amount of money will increase. Now that I have the slope and the y-intercept, remember that we can rewrite this equation, y equals mx plus b. Our equation would then be y equals 5x, since our slope is 5, plus 100, since our y-intercept is 100. Now we're going to use the equation to find when you will have $310 in the account. This is when you have to decide whether you're going to plug it in as x or plug it in as y. Since 310 is money, that must mean that it is y. And then we're going to solve for x, which is time, which if you're looking at it, since we're trying to find when we will have $310, we are trying to solve for x. So I'm going to write my equation now with 310 plugged in as the y. So 310 is equal to 5x plus 100. And then we solve. Your first step would be to subtract this 100. And then we get 210 is equal to 5x. Our final step would be to divide the 5. And when we divide the 5, we get that x is equal to 42. Now remember that this is time, and it is time in weeks. Therefore, it would take us 42 weeks to have $310 in the account. Now, in the following two examples, our given information is not going to be so clear-cut in the sense that we're going to have slope and y-intercept. We'll have to use the given information in point-slope form to be able to write the equation in slope-intercept form. So in this example, it says Martha was given some spending money and was using it to buy cookies at a rate of $3 per day. After 14 days, she has $68 left. The amount left depends on the number of days that have passed. Our independent and dependent variable is given to us in that final statement. Since it says the amount left depends on, that means that the number of days is our independent variable. So x will represent our time in days. And since the amount left, the amount of money left, depends on that, that's going to be your dependent variable. So the dependent variable will be the spending money. That she will have left. Now we're going to write out what is the given information. We have the rate. So the rate, that is your slope. The slope is $3 per day. Now since she is using it to buy cookies, that means that she is going to have less spending money left the following day. So since her amount of money is going to be decreasing, our slope is going to be a -3. Additionally, we are told that after 14 days, she has $68 left. Remember that X represents days and Y represents the spending money. So this is the number of days matched with its appropriate spending money. That is going to be a point. So we have the point 14, 68. Since I have a point and I have a slope, that means I'm going to have to use point slope form, which as a reminder is y minus y1 equals to m times x minus x1. I'm going to take the point that I have and the slope and I'm going to plug it in. When we do that, we get y minus 68 is equal to -3 times x minus 14. To get it in slope-intercept form, you only have 2 steps after this. The first one would be to distribute the slope. When we do that, we get y minus 68 is equal to -3x plus 42. Your second and final step would be to isolate the y by either adding or subtracting whatever is next to it. Since we have a -68, I'm going to have to add the 68 in order to get the y alone. Once I do those 2 steps, you have the equation in slope-intercept form, which would be y equals -3x plus 110. Now that we have the equation, we're going to use the equation to find the amount of money she began with. Keep in mind that your y-intercept, which is b, is also your starting point. In the context of this problem, that means that that is how much money she started with. So we don't even have to plug anything in, we just look at the equation. Our b is 110. That must mean that she started with $110. In our final example, let's see how to determine our independent and dependent variables. It says, suppose a 5-minute overseas call costs $5.91 and a 10-minute call costs $10.86. The cost of the call and the length of the call are related. These are your independent and dependent variables. Now, the length of the call is going to affect how much the call costs. Therefore, the independent variable is going to be the length of call. And as you can see from the 2 scenarios that were given, the length of calls is in minutes. Our dependent variable is affected by the length of the call, which would be the cost of the call, which is obviously in dollars. Now in the problem, we're going to write down what is given. We are told that a 5-minute call costs $5.91. These are related to each other. This is 1 point. Since this is time and this is the cost, This is your x value. This is the y value. So one point that we have is 5, 591. Then we're also told that a 10-minute call costs $10.86. This is a second point, 10, 10.86. Now see here we have 2 points. And in order to use point-slope form, we first need to find the slope. As a reminder, slope formula is y2 minus y1 over x2 minus x1. So let's say if I label this as x1, y1, and this will be x2 and y2. And we plug it into slope formula. We would do y2 minus y1, so 10.86 minus 5.91 over x2 minus x1, which is 10 minus 5. If you were to do 10.86 minus 5.91, we get 495. And then we would have to divide it by 5. When we divide by 5, we get that the slope is 0.99. This means that it costs 99 cents per minute for the call. Now that we have the slope and we have 2 points, that means that I can use point-slope formula to write my equation in slope-intercept form. So I'm just going to go ahead and use this first point that was given, but it does not matter which point you choose. You can plug in whichever one and you'll still get the same equation. If I'm using that first point, we would have y minus 5.91 is equal to 0.99 times x minus 5. Just as before, we have 2 steps. We distribute. So y minus 5.91 is equal to 0.99x minus 4.95. Then your final step would be to add the 591 over to the other side. When we do that, we get our equation in slope-intercept form, which will be y equals 0.99x plus 0.96. Now we're going to use this equation to answer these follow-up questions. How long can you talk on the phone if you have $12 to spend? Since 12 is money, that must mean that we're going to plug it in for the y value. So we would use our equation and substitute y with 12. So 12 is going to equal to 0.99x plus 0.96. And now we solve for x. Our first step would be to subtract this 0.96 to both sides. When we do that, we get 11.04 is equal to 0.99x. Our final step would then be to divide this 0.99 to both sides. From here, we would get that x would equal to, and when you divide 11.04 by 0.99, you get 11.15. Remember that x represents the length of the call in minutes. So this means that with $12 to spend, we can talk on the phone for 11 minutes, 11.15 minutes. Or you can round it to be about 11 minutes. Our final question here says, how much would it cost to make a 22-minute phone call? Since this 22 is in minutes, that must mean that it is an x value. So I'm going to plug it in as x. So we would get our equation, y is equal to 0.99, and instead of x, I'm plugging in 22, and then we're going to add the 96 cents. So here we go. We would do 0.99 times 22, which gives me 21.78. And then we add the 96 cents, which gives us 22.74. Now remember, y represents cost. So this means that it would cost us $22.74 to make a 22-minute phone call.